Hello, dear learners. When you are attending a maths lesson with me, please get ready with a book, pen, and your calculator. In the last lesson, we were discussing about questions with the restrictions. And with the restrictions, you also have to know one thing. That is, to find the number of arrangements that do not satisfy a restriction, you calculate the total number of arrangements minus number of arrangements that do not satisfy the restriction. You can write this as a note. Okay. While you are writing, let me go to this one question here. Okay. This lesson is part 3 of counting principles. Here we are going to start with the repetitions. That means, let's take this example of the word poppies. You can see that P is repeated here. How do you handle such situations when there are repetitions of letters? So in this example, how many ways can the letters of the word poppies be arranged without restrictions? If each arrangement begins with a P and so on. Let's start with the question number 1A, that is without restrictions. So we know the letters of the word poppies can be arranged without any restriction in first word. So always when you have a question, you can always check the number of positions, how each positions are filled. That's what we always check in counting principle. So the first position can be filled in 7 different ways because there are 7 letters available. So it's 7. Now 6, 5, 4, 3, 2, 1, which is called 7 factorial. But this is not the answer here because of the repetition of the letter P. But P is repeated 3 times. So in this case, the answer is 7 factorial divided by 3 factorial. That's what you do in repetitions. Okay. Now let's go to 1B. If arrangement begins with a P, so what happens if the arrangement is beginning with a P? That means you already know the remaining positions are there. We only concentrate on the first one, that is where there is a restriction that the arrangements must begin only with a P. So because there are 3 P's and they are repeated, actually you can take 1 P and say it's 1 here. It's already fixed. 1 P is used here. That means the remaining 6 positions can be filled in how many ways now? 6 factorial ways, because here it's 6, then 5, 4, etc. So the answer here is going to be 1 times 6 factorial. So the 1 stands for the 1P. That means if you used 1P in the first position, how many P's are still remaining here? There are 2 P's that are remaining. Because there are 2 P's, you divide the 6 factorial by 2 factorial. So this is 1 times 6 factorial divided by 2 factorial. So the 1 was for the 1P in the first position. So remaining 6, but 2 in the remaining 6 letters, 2 P's were repeating, so divided by 2 factorial. Now we are going to see. In C, the question is, if the first 2 letters are P. So if the first 2 letters are P, that means the restriction is on the first 2 letters now. First 2 letters must be P. So you take 1 P there, another P there. How many letters are remaining? you take 2 already, so remaining 5. So it's going to be 5 4 3 2 1 now. So we know that last part is going to be 5 factorial. Do you have to divide this time? Check, you already took 2 p's for the first 2 positions, so in the remaining 5 letters only 1 p is remaining, so no repetition, only 1 p, so you don't need to divide. So the first position is filled by 1 p, second position is filled by another p, so that is answer. So final answer will be 120. Okay, now D. If all 3 p's are together, okay, so the together, the grouping is also coming here, so the p's are together, that itself means the 3 p's in one box, one pack. Now p's are together, so how many letters remaining if you took all the p's in one pack? So you are still left with the 4 letters. 4 letters are still there, so this one is now counted as 1, then the remaining 4 letters, 1 2 3 4 5, all together there are 5 letters can be arranged in 5 factorial ways. Then, and there are no letters that are repeated in the 5 remaining letters, sorry, 4 remaining letters, so you don't need to divide by anything for this 2 3 4 5. There are 4 plus 1 5, that's the 5 factorial that we wrote here. Now we are considering the pack. In the pack you have a 3 p's, which is 3 factorial, but 3 is repeated, so you divide by 3 factorial. P is repeated 3 times, so divide by 3 factorial. So the answer is still 120. Now E. If the first letter is a P and the second is not a P, first letter is a P and the second is not a P, that means first letter is a P, second one is not a P, so this is a P. So the only restrictions are in these two positions. The remaining, there are 5 positions still remaining, so no problem with those 5 positions, so 5 factorial. Now all what you have to check for, I am writing this only for the remaining 5 positions. I'm still going to write what happens in the first 2. Okay, let's start with the restrictions first then. So here P means 1 P we took. Here it should not be a P. So what are the possibilities if it shouldn't be a P? There are, when the 3 goes, there are 4 remaining letters which doesn't have any P. So there are 4 choices in the second position. So it's 1 for the first position, 1 P, 4 choices for the second position. Then in the remaining 5 letters, are there any repetitions in the remaining 5 letters? You used 1 P. So there are 2 p's here. So you divide the 5 factorial by 2 factorial. So this will be the answer. So the answer will be 240. So here, let me show you the question once more. The question says the first letter is a P and the second letter is not a P. That's what we saw here. I hope you understand. If you have any doubts, write your doubts in the comment box. Okay, now with this we are going to probability now. Remember, in probability, the formula for finding the probability of any event is equal to number of outcomes of the event divided by total number of outcomes. We say total is the sample space, that's why we are using NS. So probability of an event is number of outcomes of the event divided by a total number of outcomes. Mm, I was just going through the basics in the first part 1 of counting principles. Those who are watching this part 3 of counting principles must make sure that you have watched part 1 and part 2. Okay, in probability, now let's consider this question. Consider the word maths. How many different 5-letter arrangements can be made using all the above letters? How many different 5-letter arrangements can be made? So it's still on. So now you must be very careful when you are writing in the examination, and if you see a question like this, when you read, if the question is how many different, no problem, that is what we have been doing so far. But look at the second question, determine the probability. So here you saw the word probability, immediately underline and you just write, not to forget. You here now you have to divide by the total number of outcomes. So when you are doing in the examination, just not to forget, because we are very used to finding the number of arrangements, number of outcomes of the event. That's what you are used to find. So not to forget that you have to divide by the total number of outcomes. When you read the probability word, you underline and write it on top. Okay, as a reminder. Now let's go to the question. Number 1, how many different 5-letter arrangements can be made using the above letters? So we know here you have 1, 2, 3, 4, 5 positions to fill. How do we fill in the 5 positions with the 5-letter? You already, there is no repetition here. Do you see? No repetition, nothing. So now you know that it's 5, 4, 3, 2 and 1. That's how you arrange without any restrictions. It's 5 factorial ways, and 5 factorial is 120. So the answer is 120. Now look at number 2 now. Determine the probability that, so now the question is about a probability that the letters S and T will always be the first 2 letters of the arrangement in question 1. So now there's a restriction in the event. Sorry, S and T will be the first 2. Okay, so it will be S or T. We don't know which can come first. It can be S or T. That means here it can be T or S. Anyone can come. So S and T will be the first 2 letters. So these are the restrictions. That means here what? So here it can be S or T. So that means 2 choices. Now you used 1, so remaining 1 choice. So it's 2 factorial here. Remaining how many letters remaining? 3 letters. So there no problem. It can be any of the remaining 3, then 2, then 1. That is happening with the next 3 positions. So the final answer here is going to be 2 factorial for the S and T and 3 factorial for the remaining 3 positions. This is only the number of outcomes of the event. The event here is S and T will always be the first 2. What is without any restriction? That comes the denominator, which is the NS. So the denominator here is going to be 5 factorial without any restrictions, because you are finding the probability this time. So there must be a division by the total possible outcomes in the whole sample space. That means without any restrictions. So the final answer here is going to be 1/10. Okay, that is probable. So probability is not that difficult, just that you have to remember it's going to be a fraction. Now we are going to see this question. These are examination questions as it is. It's one question 12 in the examination. In the examination, you always have the last question, the probability question. That's why it's number 12. Okay. Now, let's see the question first. 12.1. A password consists of 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if 1. All the letters of the alphabet can be used? Okay. So here it's about the letters of the alphabet. So we are going to do 12.1.1 first. Remember to write the positions before we go to the answer. Consists of 5 different letters of the English alphabet. So these are the positions. Now it's very easy if you write the positions and think about how do you fill in each position. That is an easy way to do counting principles. So in the first position, how many choices do we have here? So each letter may be used only once. That means no repetitions are allowed. How many passwords can be formed if all letters of the English alphabet can be used? How many letters are there in the English alphabet? There are 26 letters. So any of the 26 can be used in the first position. That means in the second position, you can use any of the remaining 25. Then third position, any of the remaining 24, then 23, then 22. So the final answer for 12.1.1 will be 26 times 25 times 24 times 23 times 22. Don't forget to write an answer. Okay, I don't have space here. Let me move this down. Okay. Okay, what is going to be the answer here? You put this in the calculator and write the answer. I think I wrote an answer here which is 7, 8, 9, 3, 6, 0, 0. Don't forget to write the final answer always using the calculator. Let's go to the second question now. 12.1.2. The password must start with the D and end with an L. So here again we are going to use English alphabet, but there are restrictions in 12.1.2 now. So the positions are still the same. The positions are still going to be 1, 2, 3, 4, 5. What is the restriction here? The password must start with a D and it must end with the L. So these two letters are already used. Only one D in the English alphabet, only one L in the English alphabet. So those two letters are already used. So how many letters are still remaining? 26 minus 2, 24 are still remaining for the second position. That means 23 for the third position, 22 for the fourth position, now 1 for the last position. So this is a situation in 12.1.2. So when you write the answer, you will say the answer is going to be 1 times 24 times 23 times 22 times 1. Remember, this is not a probability question, so you don't need to divide by anything. So the final answer will be 1, 2, 1, 4, 4. Okay. Now we are going to 12.2. 12.2 you can see there on top. 12.2 is 7 cars of different manufacturers, of which 3 are silver, are to be parked in a straight line. 12.2.1, in how many different ways can all the cars be parked? So still not a probability question, so we are just writing the number here. Okay, let's write the answer. 12.2.1, 7 cars. So here we have 7 positions now. 7 positions, 3 are silver. In how many? All 3. So no restrictions in 12.2.1. How many different ways can all the cars be? How many are they? All the cars are 7. So we're starting with 7, then 6, 5, and etc. So that is called 7 factorial. If there is no restrictions, that is simple 7 factorial. And 7 factorial is 5040. Okay. Now 12.2.2. It's now that there is a restriction now. 12.2.2. If all 3 silver cars must be parked next to each other, that is a pack now. All the 3 silver cars are in a pack now. How many remaining? How many cars are remaining? 3, then 4 cars are still remaining. So it's 1, 4 cars are still remaining. Cars. There are 4, these 3 cars are silver cars, remaining 4 cars. So when we count, you count this as 1 pack. So it's 1, 2, 3, 4, 5. We count it as 5 cars now. So we can say the number of arrangements is 5 factorial. Now you consider the pack. Pack of 3 can be arranged in 3 factorial ways because there are 3 cars. The 1 silver can be parked first, or the other one, or the other one. So that's why it's 3 factorial. So the final answer is 5 factorial times 3 factorial. The value is 720. These were examination questions. Okay. So we are just learning how we use all what you learned in groupings, repetitions, and all that. Okay, now let's go to the last question. The letters of the word decimal are randomly arranged into a new word, also consisting of 7 letters. How many different arrangements are possible if letters may be repeated? So it's 11.2.1 says letters may be repeated. How many letters are here? Decimal means 1, 2, 3, 4, 5, 6, 7 letters are there. So letters may be repeated means first position can be any of the 7 letters. Second position can be any of the 7 again. It can be repeated. That is the meaning of it. So the answer is going to be 7 times 7 times 7, 7 times, or you just say 7 to the power 7. That will be the answer. So use the calculator to get the final answer. 7 to the power 7. The answer is 8, 2, 3, 5, 4, 3. Okay. 11.2.2 now. Letters may not be repeated. So what happens here if it may not be repeated? You start with 7, then only 6, then 5, like that. What do we call it? That is called 7 factorial. 7 factorial is 5040. 7 factorial. Now 11.2.3. The arrangements must start with a vowel and end with a consonant, and no repetition of letters is allowed. So here also the question is not about probability, but here in 11.2.3 there is a restriction. So arrangement start with a vowel and end in a consonant. No repetition is allowed. Okay, how many vowels are here? In decimal we have E, I, A. These are the vowels. So there are 3 vowels, and so that means the remaining 4 letters are consonants. So first letter must start with a vowel. That means we have 3 choices. And the word must end with a consonant. That means we have 4 choices there. How many letters are still remaining? 2 letters are gone out of 7, so 5. 5 letters can be arranged in 5, 4, 3, 2, 1. So the answer here is 3 times 5 factorial times 4. That is answer. 3 times 5 factorial times 4. The answer is 1440. Okay, that is all. I don't know, in the past they used to give a lot of marks in the examination. It was a November 2015 question paper, that is why it has got 4 marks. So if it's 4 marks, it's going to be marked like this now. So you get a mark for each step there. For the 3 you get 1 mark, 5 factorial you get 1 mark, 4 then also for the answer. That's how you get the mark here. Okay, learners, now actually we covered everything in probability now, but there are still a lot of questions in the examination that you get. So you can ask any question in the comment box. I will try to answer them in the question and answer session. Thank you for watching.